So, last time we left off with the idea of inverse functions, and I said that inverse functions can be useful in several different ways. So, let's start out with a function here. So, something simple. Let's say f of x is equal to something like, let's put it in standard form, 2x, let's say plus 5. Again, something real simple. So this is just a function. We can have any kind of function out there. But if we want to find its inverse, what we're going to do is we're going to find a function that does the exact opposite of this. So last time, what I was saying is if this function takes x and multiplies it by 2 first and then adds 5, we're going to need to have a function that does the exact opposite of these operations in the opposite order. So, like the opposite of multiplying this x by 2 would be dividing the x by 2. The opposite of adding 5 would be subtracting 5. And if we do multiply first, then addition second, well, what we're going to have to do in our inverse function is subtract first, then divide second. Now, this one's so simple that we could probably just kind of figure out what it is by looking at it for the inverse function. However, it is always a good idea to go ahead and go through the steps of finding an inverse function. So the first step in finding the inverse for this function is to change f of x back into y. We want to make this a generalized equation again. We don't want it to be in the form of a function. We want it to be y equals. And part of that is because it's just easier to write y equals. Also, when we are talking about getting an inverse function, what we're doing is we are literally switching our x's and y's. So if we look at the graph of a function, look at the graph of an inverse function, which I'll actually do in a few minutes for us here, the x coordinates and the y coordinates are switched. So like if we had the coordinate 2, -1 somewhere in our original function, in our inverse function, this would change into, that's a bad arrow, this would change into -1, 2. Again, literally, the x's and y's switch in our inverse function. So if my x is 2 and my y is -1 in my original function, in my inverse function, that point is going to flip over to my x being -1 and my y being +2. So now that I've got my generalized function here, I want to switch my x's and y's. So any x that I have over here, it's going to switch over to a y. Any y that I have over here, it's going to switch over to an x. So this is now going to be x equals 2y plus 5. Oops, 5. Okay? So now that we've gotten this, what we want to do is we want to solve this for y again. So, we're just going to have to move the 5 and the 2 over to get this solved for y. So the first thing we can do is subtract 5 from both sides. So that's going to give us x minus 5 equals 2y. And then divide by 2 on both sides. And that is going to cancel there and give us x minus 5 over 2 equals y. So I'll go ahead and write that again up here. Whoops, x minus 5 over 2. Now, the last thing we need to do to finish this up and get our inverse function is to actually write this as a function. And so that's just change y back into f of x. But not just f of x. We want to say that this is the inverse of this one. So when we change this back to f of x, we're going to write that as f to the negative 1 of x. Because remember, a power negative 1 takes the inverse of a number. So if we write this as f to the negative 1, we're saying, okay, this is an inverse of this one. Okay. So we have our original function, and again, what I said was this one takes x, first multiplies it by 2, and then adds 5. And what we needed was something that did the opposite. So the opposite operations in the opposite order. So here in our inverse function, it takes x, subtracts 5, and then divides by 2. So yeah, that's the opposite operations in the opposite order. And I'll go ahead and pause real quick for any questions we may have. Okay. I'm not seeing any questions yet, but if you have one, just go ahead and ask. So again, what I said before was that with these inverse functions, the x's and y's flip. And so I want to actually show y'all that. And bear with me for a second here, because I'm going to have to do some technical things to get this to show up. Let's see here. Add window capture. Is that going to show up? It's not going to show up. All right, we'll have to do this by hand. That's fine, though. So let me just import a graph real quick. All right, so let's graph this thing. So our original is 2x plus 5, and remember that we can actually get some information out of this because it is in slope-intercept form, where the number in front of x is the slope, and the constant over here that we're adding to it is the y-intercept. So we can go ahead and put our slope and our intercept onto this graph, and we'll be able to see our graph pretty quickly. So I'll just put some points on here real quick. So if we have a slope of positive 2 and a y-intercept of positive 5, what I can do is I can put a point on positive 5 on our y, because that is our y-intercept. And then I can use our slope of 2 to say that's really 2 over 1 as a fraction. So we're going to be going up 2 and then over to the right 1. So we've got another point here. Up 2 over 1, we got another point here. And so on and so forth. I've got 3 points though, so I can go ahead and make my line. And what color do I want this line to be? How about blue? Ooh. Yeah, that's probably good enough. So we've got a line that looks like this for our original function. That's our f of x equals 2x plus 5. Okay, so what about this one over here? What about our inverse function? Well, I'm going to have to rewrite this just a little bit in order to get this to be in slope-intercept form. So this is both of these being divided by 2. So if we rewrite this a little bit, I'll make this a different color. This would be x divided by 2, so 1/2 x. And this would be negative 5 divided by 2, so minus 5 over 2. Okay. So this is the slope for our inverse function and the y-intercept for our inverse function. Okay, so now just the same way, we want to take these two pieces of information and graph them. So first of all, our y-intercept, negative 5 over 2, is really about negative 2.5, I think. Yeah, that's right. So negative 2, then 0.5 is right there. So I'm going to have to put a dot here between negative 2 and 3. So where's that? Yeah. Okay, and I'll switch up the fill. Let's make this line green. All right, yeah, it looks good. All right, so then the slope tells us that we're going to be going up 1 and over to the right 2. So up 1, over to the right 1, 2. That's a point there. Up 1, over to the right 1, 2. That's a point there. Up 1, over to the right 1, 2. That's a point there. So now get the line and make our line here. Let's see, that would be line going about like that. So what we can see here is that these two lines on our graph mirror each other. So, like I said, the x's and the y's switch, and they mirror across like this. Now, I could also, instead of having to go through, using my slope and my y-intercept, I could have switched these points, switched my x's and y's. So if this one is x equals 0 and y equals 5, then I can switch that and make it x equals 5 and y equals 0. Well, hey, yeah, right there is that point, and it does follow my inverse graph. So the original point here translated to over here. Okay, what about this point? This is x equals 1, y equals 7. So if we flip that, that would be x equals 7, y equals 1. Again, there's the point, and it is on our graph. So, like I had been saying, when we take an inverse function, we are literally switching the x's and y's. So every x and y here switches over, they switch places and give us our inverse function. So all of the points here on this line switch their position, so x's and y's switch, and they give us this different line, this inverse function, the exact opposite. Okay. But let's keep going. So something else that I had mentioned on Friday is that these inverse functions help us find range. I didn't actually show us how they found range, but I just mentioned that they do help us find the range. Now remember that when I say range, I'm talking about things like domain and range, where domain is all of the numbers that we can plug in for x, all the things that it's okay to plug in. Y, it has the same idea, but we call it range, just to make a distinction between the two. So range is all the things that we can have plugged in for y. Okay, so let me give us a function here real quick. Let's do g of x. Remember, just because it's not an f, but a g instead, doesn't make any difference. The f or the g or the h or whatever's there is just the name of the function. So g of x equals, let's say, 2 over x plus 3. Okay? So, The first thing we really ought to do anytime that we're looking at a function is find the domain. Before we start plugging things in, before we start finding inverse functions, before we start doing anything, it's always a good idea to know what our domain is. And remember, domain is what x can be. And there's two things that you want to look for when we're looking for domain restriction. First of all, do we have a fraction? Yes, actually in this case we do have a fraction. So what we do is we take the bottom part of that fraction and we say it cannot be equal to 0. So x plus 3 this cannot be equal to 0. And the reason we say that is because if this part down here ever becomes 0, then we will have 2 divided by 0. Well, we can't divide by 0 in algebra. That gives us an undefined answer. And so how do you graph that? The answer is you don't. So again, this bottom part needs to never be equal to 0. So that's why we take the bottom part and say, all right, no matter what this is, can't be equal to 0. And now we need to solve for x, which pretty easy here. We just need to subtract 3. All right, so that cancels here, leaves us with just x on this side. And so x cannot be equal to -3. There is our domain. This is the rule for what we can and cannot put in for x into our function. The rule says we can basically put anything in there except for -3. If we plug -3 in there, breaks the whole thing. So any real number works except for -3. Okay, so that's our domain. But again, I want to try to find the range for this one. So I'm going to need to find my inverse function. Okay, so we need to take this and generalize it. Make g of x into y. That's our first step for getting the inverse function. So now y equals 2 over x plus 3. Now, again, inverse functions flip x and y. So we're going to change the position of x and y. So any x's over here become y's. Any y's over here become x's. So this is now x equals 2 over y plus 3. Okay, and now we need to solve for y, get y by itself. All right, well, in this one it's a little bit more difficult, and that's because of this fraction. We don't really have a way to get just y by itself with simple steps. What we're going to need to do is we're going to need to get rid of this fraction. So I'm going to actually multiply this whole side by y plus 3. What that does for us is it cancels out on this side, leaving us with just 2. However, on this side, we now have x times y plus 3. Okay. So now we don't have any fractions, and that's a good thing. That we wanted to get rid of that fraction because it was giving us some trouble. Now we can just divide the x off of this side. That cancels there. And divide x here. So now we have y plus 3 equals 2 over x. Okay. And then the y plus 3 over here, well, I can't have 3, I just need to get rid of that 3. So subtract 3 from both sides. And that gives me y equals 2 over x minus 3. And there's my inverse function. So f to the negative 1 of x, to show that we have an inverse now, is equal to 2 over x minus 3. Okay. Now, there's actually something that we forgot to do. Remember that I said when we get the inverse function, we flip x's and y's. So any x's over here become y's, and any y's over here become x's, which we did here, but we didn't do it here in our domain. We need to flip all of our x's, and that includes our domain. So if our domain says that x cannot be equal to negative 3, we flip that, and over here for our inverse function, y cannot be equal to negative 3. So we get a range, but it's for our inverse function. We don't want that, though. It's nice to know. What we wanted to know, though, was the range for our original function. Well, if it works here to take our domain and change it into the range for our inverse, then it must work for us to get our domain for the inverse and make it the range for our original. So, what is the domain for our inverse function? Well, we have a fraction here. The bottom of this fraction is x. And so we have to take whatever's there on the bottom of that function, or on the bottom of that fraction, and set it not equal to 0. And that's our domain, which then becomes the range for our original. And there we go. We got our range. So our domain says that x cannot be equal to negative 3, and our range says that y cannot be equal to 0. And again, the x's and y's flip in inverse functions, so our range for our inverse function is that y cannot be equal to negative 3, and our domain is that x cannot be equal to 0. So if we want to find the range for our original function, we find the inverse, like we did here, and then the domain for this inverse becomes the range for our original function. Again, the x's and y's flip, so the domain flips to our range. And I will pause for any questions we may have. Okay, I'm not seeing any questions, so I'll move on. Okay. So, something that I noticed in Hawks is something that we've actually gone over, but I want to make sure that we see the way that Hawks is showing it to us. So, remember that the way that functions work, and I'll make a function real quick, h of x, is that we can plug in numbers for x here, and then it will process it with whatever rules we put over here. Oh, Victor's got a question. How do you get the x and y not equal to 0? Okay. So remember over here, in our inverse function, we also want to find the domain. So we found the domain for g of x over here, right? And we said that if we have a fraction in our function, that what we want to do is take the bottom part, in this case x plus 3, and set it not equal to 0. And then we solve, and so that gave us a domain for our original function of x cannot equal negative 3. Right? So over here, we also want to find the domain for our inverse function because that's going to give us the range of our original function. Well, just the same way as this one, we took the bottom of this fraction, set it not equal to 0. We take the bottom of this fraction and set it not equal to 0. So if we do that, we take x, say, all right, this thing cannot be equal to 0, and there we go. We don't need to solve anything. It's already solved for us. And so because the domain of our inverse function is the range of our original function, we can just flip this to y is not equal to 0 for our original function. Again, remember that inverse function and original function flip all of your x's and y's. So this x over here becomes a y. That's now our range instead of just the domain over here. Does that help? Okay, cool. Always like to see questions. All right, so like I was saying, remember that if we have a function, what we can do is we can plug in numbers for x here, and it will process them over here with the rules, whatever they may be. In this case, multiply by 3, then subtract 7. So if we plug in a number, let's say we plug in, I don't know, 4. So h of 4. That would be 3 times 4 minus 7. Okay, so if we multiply 3 by 4, we get 12, then subtract 7, that gives us 5. So h of 4 equals 5. Now, what this means here is we have a point, a coordinate that we can plug into our graph. What we're saying with h of 4 equals 5 is that we have an x that is 4. Remember, we plugged in 4 for x. and a y that is 5. Okay, so this is a point. This is the point 4, 5. Okay? So, what we can do with this information is then say, maybe we just have a point, and maybe we just have a slope, and we want to find the original function. Okay? So, in Hawks, it's going to give you points that look like this here. Let me switch that back over. That becomes that. Okay. So in Hawks, we're going to have points that look like this. They correspond to this kind of point here. So in Hawks, if you see something like h of 4 equals 5, or f of 4 equals 5, or something like that, read it like this. Your x is 4 and your y is 5. And the reason I say that is because, again, it's going to try to get you to find a function based off of a point and a slope. So it's going to give you the point like that, though. So let's practice this real quick. Let's say that Hawks gives us a point g of 3 equals -2, and it gives us a slope of, oh, I don't know, how about 5? No, let's do just 2. Keep it simple. Okay. So think back. Remember that we actually have a function for this, or a formula for this, and that is called the point slope formula. So point slope, if you look back in your notes, again, I did say to write this down somewhere in your notes. The point slope formula is y minus y1 equals m times x minus x1. And again, this is called the point slope formula. Okay, so what we can do with this is we can take this point and plug it in for our x1 and our y1. This point is, this is our x, we plug it in for x1. This is our y1, we plug it in for y1. And our slope is m, so we take that and plug it in for m. So let's go ahead and plug all these things in. So y is just a generic y. It's going to stay y, but y1 is going to be this number right here. So in this case, -2. M is slope. M always represents slope, so 2. Times x. Again, that's just a generic x. It's going to stay x. Minus x1, which is this thing right here, the x that we have in our function. Okay, so now we need to simplify this down and get y by itself. So first things first, we can multiply. Negative times -2 is going to be +2, so y plus 2 now. equals, again multiply, so 2 times x is 2x, and then 2 times negative 3 is negative 6. Okay, just one more thing to do. We need to get y by itself, so subtract 2. So that cancels there, and we get y is equal to, let's see, if we subtract 2 from this side, negative 6 and negative 2 are going to give us negative 8. So 2x minus 8. And so there's our function. We can write this as g of x equals 2x minus 8. So again, if Hox gives you a point like this and a slope, you can use the point-slope formula to find the original function. So our original function is g of x equals 2x minus 8. Now sometimes it's not going to be nice and give you the slope. Sometimes it's going to be a little bit tricky and give you 2 points. Remember that you can still find the original function given just 2 points. So let's try that as well. So let's have f of x let's plug in something for x though. How about negative 1, f of negative 1, and that's going to give us a y of, let's say, 3. Okay, so here's 1 point here. This is our first point, and I'm going to label it as such. Okay, so then it's going to give us a second point. Let's say f of 4 equals 7. So that's our second point. Okay, so it gives us 2 points, and it wants us to find the original function. So there's a few things we're going to need to do here. First of all, yeah, we're going to need our point-slope form. So that's going to be y minus y1 equals m times x minus x1. So yeah, we are going to need that, but we're going to need something else as well because it has not given us the slope. We need the slope in our point-slope form. We need m, but it hasn't given us a slope. It hasn't given us an m. We need to find that slope. So we also have a slope formula that says m equals y2 minus y1, in other words, the change in y, over x2 minus x1. Again, in other words, the change in x. So the change in y over the change in x. And again, this is our slope formula, so I'll label that as well. Okay. So we're first going to need to find the slope so that we can plug that into our point slope formula. So again, we labeled these our first point and second point because we need to say which one is the first one and which one is the second one in our slope formula. It does not matter which one you say is your first and which one you say is your second, as long as you keep it straight when you get over here. So if this is my first point, then this right here is my x1, this right here is my y1. If this is my second point, then this is my x2, and this is my y2. So let's go ahead and fill in the blanks then. So m equals y2, which is 7, minus y1, which is 3, over x2, which is 4, minus x1, which is negative 1. Okay. So 7 minus 3, that's going to give us 4. Then 4 minus negative 1, that's really 4 plus 1 because negative and negative make positive. So 5. So we get a slope of 4 over 5. Cool. We have our m. We can move on now to our point slope formula. So point slope formula, we have y1 and x1. So we're going to be using these numbers over here. Plug in negative 1 for our x1 and positive 3 for our y1. So let's go ahead and do that. So y, just generic y, minus y1 is 3, equals m, which we found to be 4 over 5, times x, minus x1, so minus x1, which is negative 1, and now we just need to simplify and solve. So first things first, multiply. We have negative 1 times negative, so that's going to be positive 1 now. So y minus 3 equals 4 over 5 times x plus 1. Okay? And then multiply the 4 over 5 into here. So y minus 3 equals, let's see, 4 over 5 times x is 4 over 5x. And then 4 over 5 times 1 is 4 over 5. Oops. Alright, one thing left to do, and that is to get y by itself, so we add 3 to both sides. Okay, and let's see, 4 over 5 plus 3. We need a common denominator, so I'm going to need to make that a 5. Multiply that by top and bottom. So we get 4 over 5 plus 15 over 5. That's going to be 19 over 5. So all in all, give myself a little bit more room. We have y equals 4 over 5 x plus 19 over 5. And there's our function. All we need to do now is say it as a function. So f of x equals 4 over 5x plus 19 over 5. And there we go. There is our function. So again, pretty sure we went over that. I just wanted to make sure that we had seen the way that we can state a point using the f of, like -1 equals 3. So this is our x, this is our y. And it's the same thing that we talked about before with this. We use the slope formula to find our m. Then we use the point slope to plug in m and one of these points. So y1 and x1 we get from y1 and x1 here. Plug all that in, simplify, solve, and we can get our function. So I will pause for questions. Okay, I do not see any questions right now. So, let's see. Next time we should be going over 4.5. And what is 4.5? Let me just look real quick. I looked before I started today, now I can't remember. Oh, yes, that's right. So, now that we've gotten over the basics of functions, what we're going to be doing next time is 4.5, which Mr. Morzinski's already covered part of. He did that on Thursday. But 4.5 is going to be combining functions, so we can actually put these things together. Like, maybe this function that we got here is the transmission of a car, and this function here is like the engine of the car. Well, yeah, they're machines, they do things, they process power and give some kind of output, but they don't do a whole lot on their own. It is only really when we put these parts together, these machines together, that we get a overall more complex and more useful machine. So we can put these together with different types of operations, like we can add functions, subtract functions, multiply functions, divide functions, and do something called compose functions of each other. And composing functions is where we get some really powerful tools on our tool belt. But again, that will be next time, so prepare for that. And I will see y'all later, and I hope you have a good one.